La Zorana és arquitecta i doctora per la Universitat de Belgrad. Actualment és investigadora postdoctoral en el projecte Cult-Aural, finançat per una beca Marie Curie a la Universitat de Barcelona. Dins d'aquest projecte, amb el títol complet Oral Culture Decoding the Sacred Soundscapes of Medieval Europe, explora els paisatges sonors monàstics medievals, incloent els sons de grans instruments de percussió tocats a l'aire lliure. La seva investigació se centra en 3 regions, Catalunya, Noruega i Sèrbia. I el títol de la comunicació... Bé, no? Vale, sí. Porta per títol Oral Networks of the Past, pels Soundscapes in Medieval Pallars Sobirà.
Thank you. Okay. Hello, everyone, again. Okay, so I will talk about oral networks in Catalonia. As I said this morning, I think that the interest in Catalan soundscapes are much wider than the region of Catalonia itself. And I'm the proof of that because I came here as a Marie Curie postdoctoral fellow to research soundscapes of medieval Catalonia. And today I will talk about that, what we found out so far, and what is how we are going to develop our research further. So this is the title of my project. It's Oral Culture, Decoding the Sacred Soundscapes of Medieval Europe. And beside Catalonia, I'm also working in Serbia and in Norway. These 3 regions are totally different, as you can see, although they share some similarities in cultural context, such as Christianity, right? So today I'm going to talk about soundscapes of bells in 2 particular case studies. The first one is about Santa Maria da Neu. Am I too loud? No. Okay, only here is a bit. Okay, so first one is Santa Maria da Neu, and that was the initial case study of my postdoc. My postdoc is close to finish, so I have only several more months to go. So I'm trying to put all the data that I collected, to put it together and to make some sense of it, right? So we wanted to understand the soundscapes around Santa Maria da Neu, so I will explain that. And the second is actually what came out from the conclusions of this case study. And that is particularly now, we will look at Santa Maria de Geri and the network around it. It will be clear at the end. Okay, so the research question about Santa Maria da Neu was that this church has an impressive architecture, and more to it, there is the paintings inside the church. But its ecclesiastical significance was not clear because we don't have enough of historical data. This church never had the parish status, and it never developed the surrounding population. So the question was, this is Aneu Valley, and here as this black dot, you can see Santa Maria da Neu. And since we didn't know, and we still don't know what was the role of this church in Aneu Deanery, we also didn't know what is the center of Aneu Deanery. So this soundscape and visibility also study should give us some clue about that, to see if we can use it to argue its role in the deanery. Here on this panoramic photo, you can see where the church is. Right? No, you don't see. Okay, so you can see where the church is, and these are some shots from in front of the church, so from the entrance. So the question is, did Santa Maria d'Aneu have the auditory capacity to initiate the deanery's oral network? So could it start sending broadcasting the message throughout the deanery? We are considering sound as a way of power, right, in this context. So what we did, okay, first thing, when I'm talking about we and why I came to University of Barcelona, I came because my supervisor, Margarita Díaz-Andreu, is here at the University of Barcelona. And they, in this project, Artsoundscapes, they developed a methodology how to explore outdoor soundscapes. So prior to this, I was working indoors. So I was working in churches. And now I'm here, and thanks to Marga, I was integrated in her research group. So these studies I was doing with Lidia Álvarez Morales, who is an acoustician, and also with Xavier Costa-Badia, who is a historian. Of course, I wouldn't be able to track all the historical sources on my own, especially because they are in Catalan. Okay, so what we did, the methodology of this research is that first we did some acoustic measurements. Here you can see what we usually use. It's a sonometer, and we use recorders. So from recorder we get audio files. From sonometer we get a huge Excel table with numbers quantifying what is happening with sound in every single second. Based on that, we did the simulation. I will explain that, and visibility study. So at the end, like crossing the results from soundscape study and from visibility study, we tried to make some conclusions. So the simulation, we did first we did the measurements in these two receiver points. The blue dot is the bell gable of Santa Maria d'Aneu. So we were ringing bell from there. We were ringing from the ground, no, actually from the gallery, because rope was coming to the gallery. We couldn't go all the way up to the bell. And we were recording with sonometer and recorder on the point of receiver 1, which is on the ground level, and also receiver 2. Maybe you can hear. And receiver 2, that was particularly important because only with at least two receiver points, we could actually validate the simulation. So the simulation we did in ArcGIS in desktop version, which is a bit outdated, but only in that version we have the plugins that work with sound, such as sound mapping tool. This sound mapping tool is based on the SpreadGIS script, and this script takes into account these 6 different parameters. The first one is spherical spreading of sound. The second one is atmospheric absorption loss, which means that it takes into account humidity and temperature, because especially due to temperature, it changes the spreading of sound, and due to humidity, but in some, let's say when we have a higher percentage of humidity, it changes drastically. Then ground cover loss. It also takes into account wind and terrain effects, of course. It is the most important, I think. And it also gives us an option to understand how much sound we can hear above the background noise. So we used digital elevation model, which is freely available, and national land cover data to understand, to have mapped the land covers. And from the measurements we did on site, we extracted this frequency table. This table goes from 500 to 2000 hertz. And for each of these frequencies, we extracted what is the sound pressure level. And this is what we used for the simulation. We ran, in order to validate the simulation, we needed to recreate exactly the same conditions as we had in the time of measurements. So that would mean temperature 18 degrees, humidity 30%, and no wind. When we got this kind of maps, So we still have our position of receiver 1 and receiver 2. So we needed to go back to the map to check if at those positions we have exactly or close enough values as we had in our measurements. So we had close enough. It's about 3 dBs difference, which is quite okay for the simulation. We need to keep in mind the simulation is actually an estimation, right? So we are trying to figure out how far the sound of bells spread and propagates around in the landscape, but it is actually an estimation. So we created 6 different scenarios. Basically, the point is that scenario A is what we had at the time of measurement. Scenario B is extreme cold winter day with and without wind, and C, warm summer day with and without wind. It is also based on historical data that we have for the region. Finally, we got these maps. And you can see on the right side, you can see all the scenarios with wind. So the area that sound of bell covers is significantly smaller, which is expected, but maybe it did surprise me a bit. I didn't expect this much shrinkage of the area of cover. What is also important, I think that on the top, in the right, in the left angle up, you can see that, oh, I have a better map, wait. No. I will go back to this. But I'm going to talk about this top left map because it is crucial to understand how far, what actually the sound of bells reach. Here you can see, of course, all the dots are the parishes around in Aneu Valley, and the black star is Santa Maria d'Aneu. So this is a visibility from Aneu Church. This is how many parish churches actually can see Aneu, and it is 3. It is quite high visibility in comparison to other parish churches in this deanery. And this is the most important, I think, part of the visibility study, is that we actually here can see 3 clusters of visibility, and the largest one is around Santa Maria d'Aneu, which means that Santa Maria d'Aneu has this really central point being located in the plain, and it has the highest number of connections, visibility connections with other parish churches. This is very similar to what we have from our sound map. So one results corroborate the others, right? This is what I wanted to discuss. In this map here, you can see that sound from Aneu is reaching at least 3 parishes. So number 10, 12. You can see this is Esteri d'Aneu, it is a village. So it reaches the village, and also number 14. But it is very close to these parish churches, 13, 15, 16, 17, and 18. As you can see in this table, it is about from 200 to 400 meters away from this map. Again, the map is estimation, so it could be a bit closer or further, but we are there somewhere. So in the discussion of this study, we actually realized that wind is making a huge difference. Also, the land cover is making a difference. What we don't know, I mean, there are some studies and assumptions how land actually looked in medieval period. Definitely didn't look like it is today. There were not so many forested areas, but the forest was on the hill slopes, and everything else was more or less used as agricultural land in terraces. We can still see that, particularly around Santa Maria de Geri. Okay, so we can go further. Yeah, so because of that, we also realized that for Santa Maria d'Aneu, we used the bell from Aneu, which we couldn't reach. We didn't know much about that bell. We knew for certain that it wasn't medieval. So we wanted to use the medieval bell from the region. And we went to Sant'Andreu de Pujol. Laura de Castellet was writing about it. It is a bell from the end of 13th century. And we did the measurements there, trying to understand to do the tonal analysis of bell. And here on this photograph below, you can see that the visibility of this church from the what used to be the main road in the region is quite high, so it is on top of a hill. Okay, so then we did the tonal analysis in Veivanel. You can see here, and what we, Veivanel usually gives at least 5 main frequencies of the bells: hum, prime, terts, quint, and nominal. But here we don't have that. You see the column where it says partials, we don't have any. But we could conclude what is the strike tone based on the sound levels that they produce and based on this graph. So that is about D3, and the frequency is 1165. So what we also understood from the spectrogram is that the sound energy is between 400 and 5,000 hertz. So it means that what we used in Santa Maria d'Aneu, actually there is more sound energy that we only looked at. So we were looking at up to 2,000 hertz, but there is more from 2,000 to 5,000. Okay, so we used another tool. We used Archaeoacoustic Toolbox, which is a bit more adapted for the research in humanities. The sound mapping tool that we initially used with ANEU is actually for spreading of sound in natural environments, but this one is more for humanistic research. Let's put it that way. So this is what we got. This is the spread of sound of bells for 1,165, okay, for D3. And we used the sound level as we got it in our measurements in Pujol. Of course, again, we recreated what we had at the time of measurements. And here you can see the parishes of Pujol. These are actually parishes of Santa Maria de Geri, and that is what we next want to do. Because Geri was so powerful at the time, we want to understand, and we also, Geri has a very high bell gable with at least 3 bells. We did recordings there, but apparently the problem with the bell ringing today is that everything is more or less in Catalonia automized. So everything is on the power, right? So no human ringing. And there is a huge difference if you have a bell ringer who knows what to do and who knows how to swing a bell, especially if there are more than one bell. In Pujol, that was not the situation, and I was able to ring the bell and to do the proper measurement. So now the next step of the research is actually to understand the oral network around the Geri. Because as you can see here in Pujol, so we were ringing bell in Pujol. In this map, you can see that its sound reaches 2 neighboring parishes. It's not covering the entire parish of Pujol, evidently, but it reaches quite an amount of 2 neighboring parishes. Basically that is where we are at the moment. So the study of ANEU is going to be published soon, but the study of Geri is something that waits for us, and where I expect a lot of results, particularly because we are using this archaeoacoustic toolbox that now allows us also to include the height of the bell tower. So now we can play more with the heights, because we know for some churches we know that height of bell towers, but for many of them we don't. So we approximate them. We can also play with the frequencies in archaeoacoustic toolbox. So we can look into one specific frequency, for example, like what is called the strike tone of a bell. And that's it, where we are now. Thank you very much.